Hello, I am one. Last week we talked about graphing linear inequalities. And as we've been talking about those, we're talking simply theoretically about x's and y's and numbers and less than or greater thans in order to plot things on a coordinate plane. And it doesn't really mean much to us unless we can apply this to the real world. This is going to be one of those things where you're going to ask the question, when will I ever use this in my life? And this might very well answer that question. We're talking about linear inequality word problems now, and you're going to be seeing a practical version of how this will help us in order to be able to plot and graph answers to our questions. So let's go ahead and go into this. The first thing I want to describe to you is this idea that there's a process for solving that I want you to understand. And the process goes like this. The first thing you want to do is identify your variables, like x and y. But you don't have to use x and y. You could use p and q. You could use really any letter that you want. If you wanted to say D for dogs and C for cats, you could do that. In this instance right here, I'm going to just kind of give an illustration of you're selling corn dogs and hot dogs. So let's let x be the number of corn dogs and y be the number of hot dogs. And then number two, write an expression. And so now you're going to be focusing on an expression. And so maybe you're talking about, in this case here, you're selling hot dogs and corn dogs, or corn dogs and hot dogs. And if you're selling them, then there's a cost related to these things. So if you're selling corn dogs and hot dogs, maybe a problem is asking a question related to how much money you would be making. If corn dogs sell for $2 each and hot dogs sell for $3 each, an algebraic expression for how much would be made would be this right here. You could be looking at this and saying, I made $2 for every corn dog and $3 for every hot dog. So this is, I'll just write dollars made right here. And so there that is. So $2 for corn dogs and $3 for hot dogs. If I add that together, that is my algebraic expression that represents how much I made based on the number of hot dogs sold and the number of corn dogs sold. So to write this as part of an inequality, now we're addressing the rest of the question. Maybe the rest of the question says that I want to make at least $120. So at least now makes us say, oh, am I saying equals? No, I'm not saying equals, because if I'm saying at least, I could be doing more than 120 and still be happy because I made at least 120. So doesn't that say then that the dollars made then has to be greater than or equal to 120, because I wanted to make at least 120. And so now our expression says 2x plus 3y is greater than or equal to 120. So that's how we make up our math for a problem like this. And let's go ahead and go into a couple of examples here. So the first example here is you are selling pizzas to raise money for a school field trip. Cheese pizzas cost $8 and pepperoni pizzas cost $9. You want to sell at least $180 worth of pizza. So let's go ahead and say that X is cheese pizza and Y is pepperoni. So if that's the case, we have now X and Y, which are variables, representing the number of cheese pizzas and the number of pepperoni pizzas. So write and graph a system of linear inequalities that represents the information given above. So we know that cheese pizza cost $8, but the X represents how many cheese pizzas there are. And so we can say 8x, and we can say plus 9y. So 8x, isn't that the amount of money made selling cheese pizza? And 9y, that's the amount of money made selling pepperoni pizza. And you want at least $180 worth of pizza. So we want 180. And we're saying at least again, so we want this to be greater than or equal to 180. We're going to be using the concept of intercepts in order to find what the far edges are. But before we do that, let's go ahead and label our axes. We said that X is cheese, so we're just going to write cheese down here on our x-axis. And for the y-axis, we said that that's pepperoni, so we're going to write pepperoni. Pepperoni. And so there's that. So now what we need to do is find out what the limits are. In other words, what's the very most that I can make in cheese pizza? Well, if I can say what's the most that I want to make and still make $180 and I don't sell any pepperoni, then we just say y is equal to 0. So we're just going to write that. Y equals 0. And if y equals 0, then we're really looking at this. 8x has to be greater than or equal to 180. And I'm going to divide both sides by 8. So I can find out what x is. So x is going to be, and we're going to divide 180 by 8. So 2, 16, leaves 20. 2 goes into that and gives 16 and gives me a remainder of 4. So I really get 22 and 4/8, which is a half pizzas. So we should round that up. Just x is 23 is really the, because we're not going to sell half a pizza. And now let's figure out y. Well, that's going to take x being 0, so that's going to give me 9y is less than or greater than or equal to 180. And divide by 9. So that's 180 divided by 9. 2 times 9 is 18. So that gives me 0, and I got to put a 0 there for 20. So that gives me y equals 20. And so those give me my boundaries. So we're going to say we're going to be 20 on the y. So I'm going to count 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and label that 20. And half that is 1, 2, 3, 4, 5. That's my 10. And so that means that these are labeled at 2s, 4, 6, 8, 12, 14, 16, 18. And let's check out the cheese. The cheese is at 23 is my biggest number, so I'm going to go ahead and mark off 20 at 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that makes 20 right here. So if that's 20, then this is 22, this is 24, and 23 is right in there. So we know that we have enough. So let's just go ahead and label these. This is 2, 4, 6, 8, 10, 12, 14, 16, 18. And so there we have it. There's our axes. Well, we have said that we can have as many as 23 cheese pizzas, and we can have as many as 20 pepperoni pizzas. So that's going to give us a solid line because of the equals to part of greater than or equals to. And there's our line. So now let's go ahead and test the origin. So the origin is going to say 8 times 0 plus 9 times 0. Is that greater than or equal to 180? Or is 0 plus 0, which is 0, greater than or equal to 180? The answer is no. So that means we're going to be shading away from the origin. So that means we're going to be going up here and shading. And there we have it. So now the next thing is to maybe even put in a point. Let's just select a random point, like say this one right here at 10, 16. So this is saying I sold 10 cheese pizzas and 16 pepperoni pizzas. So let's see what we get here. And let's see if that confirms that we are in the right zone, that we shaded in the right area, and that we've got enough made from pizzas. So we've got 8 times 10 plus 9 times 16. Is that greater than or equal to 180? Well, 8 times 10 is 80. 9 times 16, that's 90 plus 54, so that's 144. And 144 plus 80 is 224. Is that greater than or equal to 180? Yes, it is. So we reached our goal. What if someone said, hey, we sold 16 cheese pizzas and 2 pepperoni pizzas, did we make enough? Well, let's check that out. That gives me 8 times 16 plus 9 times 2. Is that greater than or equal to 180? Well, 8 times 16, that's 80 plus 48, that's 128, and 9 times 2 is 18. When I add those together, I get 146. 146. Is that greater than or equal to 180? The answer is no. Get back to work and sell more pizzas. Okay? So there's a couple of test points to show how this works and show if we're plotting in the shaded area, that's how that goes. All right, let's do another one here. In this next example, a phone company charges 20 cents for daytime minutes and 5 cents for nighttime minutes. How many day and night minutes would you have to use to be charged less than $10 in a full day? So the first thing that we need to do with this problem is actually stabilize our units. We've been given money in cents and in dollars, and we need to kind of use one or the other. We want to be either in cents or we want to be in dollars. And actually, I want to be in cents. So we're going to say 20 cents, 5 cents, and we have $10. Well, all we have to do is multiply by 100, and we get 1,000 cents. So there's that. The daytime minutes, we're going to call that X. So X is daytime minutes. And Y then is going to be nighttime minutes. So now what we need to do is we need to come up with an expression. And what are we talking about here? Well, they're talking about charging us money for minutes. So isn't it 20 cents per minute for daytime minutes? And so it's going to be 20 times X represents how many daytime minutes. And it's going to be 5 times Y, or the nighttime minutes. And if I add those together, this represents the cost for minutes for an entire day. And we want that entire day then to be less than in cost 1,000 cents. And there now we have an expression that represents on the left-hand side of the inequality the cost, the total cost for minutes, and on the right-hand side the limit at which we want to spend. And we want our total cost then to be less than, so this expression says 20x plus 5y is less than 1,000. So the next thing to do is let's go ahead and label our axes. This is the x-axis is our daytime minutes, so I'm just going to put day down there. And our y-axis is going to be nighttime minutes, so I'm just going to put night right here. And so we have to find the upper limits now of x and the upper limits of y. Well, upper limits occur when you have 0 of one of them. So if I set y equal to 0 and just use this as an equation, now I have 20x is equal to 1,000. And I'm going to divide by 20. And when I do that, zeros cancel, and 100 over 2 is 50, so I get x is equal to 50. So 50 is the upper bound for x. The upper bound for y then happens when x is equal to 0. And that's 50 minutes because we're talking about x is representing minutes. So x is 0 minutes now. How many minutes of y do we get? Well, 5 times y is equal to 1,000. And divide both sides by 5. Y is equal to 10 over 5 is 2, so I can just replace 10 over 5 with 2 and put those zeros on it, and we get 200. So there we are at 200. So what we're going to do is we're going to label the axis on our graph. And I'm going to do that by taking 10 marks and calling that on the x-axis 50. Okay, and then I'm going to take 10 marks on the y-axis and call that 200. Now we're going to mark the upper boundaries for daytime minutes, which is 50, and nighttime minutes, which is 200, and we're going to draw a dashed line between them. So that dashed line represents when we're spending 1,000 cents, or $10. And so we want to see, let's go ahead and test now for 0, 0, so that we can figure out where we're shading. So we're going to say 20 times 0 plus 5 times 0. Well, that's just going to be 0 because 0 plus 0 is 0 is less than 1,000. Is that true? Yes, it is. So we're going to shade in the direction of the origin. So there's all the shading. And so there now we're representing the graph of the shaded side, which represents when we're spending less than $10. What if I was talking 35 daytime minutes and 20 nighttime minutes? Well, let's go ahead and calculate that. That's going to be 20 times 35 plus 5 times 20. Is that less than 1,000 cents? 20 times 35, that's going to be 700. Plus 5 times 20, that's 100. That comes out to 800. Is that less than 1,000? Yes, 800 cents is less than 1,000 cents. And so that point right there that we just tested seems to work just fine. Let's do another point. Let's do a point like we're going to talk 30 daytime minutes and 140 nighttime minutes. Will that work? Well, let's find out. So we're talking now about 20 times 30 plus 5 times 140. And is that less than, go ahead and put a question mark on that, 1,000 cents. So 20 times 30 is 2 times 3 is 6 and 2 zeros, so that's just going to be 600. And 5 times 14, 140 is 700. Is that less than 1,000? Well, 600 plus 700 is 1,300. And that is not less than 1,000. So we're going to get complaints from our parents on our phone bill. So that doesn't work. So that tests outside the zone, and there you have it. So this is a clear example of how we can use real-life situations and use linear inequalities to solve, using graphing, the real-life situation. So this is part of your homework. You've got 3 questions, and they're multiple part questions, and you need to demonstrate that you understand by creating expressions and inequalities and graphing them in order to demonstrate that you understand what's going on. If you don't understand and you have questions on how to do these things, let me know. You can send me email, or you can show up to study hall, which happens from 2 o'clock to 3 o'clock, Monday through Friday. And to find the link for that, you can just go to the stream on Google Classroom and find the link and come on into Google Classroom. I've also sent that to you, so you should know how to do that. If you don't know how to do that, send me email, and I can give you the link again. All right, we'll talk to you later.